Welcome to the deep dive. It's like sometimes when you're really trying to understand like the absolute basics of how the universe works, the explanations just kind of...
I think they're missing something.
Yeah, like a key ingredient. And today, we're going to try a totally different recipe. We're diving into these sources that look at the standard model of particle physics, but from a really unique perspective.
Yeah, a non-mathematical approach. They call it phenomenological.
Phenomenological, right. So for you listening, we've got material that sort of lays out this way of thinking. And get this, it even connects to some pretty unexpected fields. Then we've got these discussions, too, about what all this could mean for things like spin networks.
Even the structure of spacetime itself.
Yeah.
It's a lot, I know. So your mission, if you choose to accept it,
is to join us as we unpack this whole alternative view of like the very building blocks of everything. And we're talking some surprising links here to philosophy.cosmology, even combinatorics. Buckle up. Okay, so let's unpack this thing. When you first encounter an idea like this, where do you even begin to make sense of it?
well, I think this first source really lays the groundwork. It takes us back to some very, very basic philosophical questions. You see, it starts with this long-standing debate between, like, Plato's idea of perfect, unchanging forms, and then Aristotle's focus on, the unique individual things that we observe. And the source makes this argument that neither one of these ideas, on its own, can fully explain a universe as diverse and interconnected as ours.
So if you only take Plato, then everything's just like an abstract blueprint. But if you only go with Aristotle, then it's all just a random collection of stuff.
Exactly. So the source proposes this solution, co-creation. And the thought is that these two seemingly opposite concepts, Plato's unity and Aristotle's particularity, actually need each other. Like, they work together, this dynamic interplay, to bring the universe into being as we know it. And then it gets really interesting because the source takes this line of thinking.
So Hindu cosmology.
Yeah.
The Brahma Chakra, right. That seems like a pretty big leap.
Chuckles. It is, but the source draws this fascinating parallel. It introduces the Brahma Chakra, which is like the cycle of creation in Hindu cosmology. And it has these two main phases. So there's Sankara, which the source describes as like the initial coming forth of the fundamental elements, the elementary particles, basically. And then you have Prati-Sankara, which is like everything else. It encompasses phenomena, life, consciousness. So you start to see this resonance, this connection between this ancient cosmic cycle and the emergence of the matter that makes up our reality.
Okay, I'm seeing a thread here. We're moving from these big philosophical ideas about oneness and distinctness to this cosmological framework that, it has its own way of describing how things originate. But where do the three gunas fit into all of this? And what about the concepts of Shiva and Shakti?
Oh, that's where it gets really interesting. So the source maps these three gunas, sattva guna, think of it as order, clarity, then rajaguna, which is like activity and change, and then tamaguna, more like stability and inertia onto what they call combinatorial variables. Okay, so think of the gunas as like these different fundamental qualities of the creative process, and they're links to, the potential for different combinations and arrangements. And then you have the creative duality of Shiva and Shakti. So Shiva represents consciousness, or like the observer, and Shakti represents energy, or like the observed. And it's this fundamental interplay, between consciousness and energy that kind of provides another layer to the framework. It sets the stage for the whole universe to unfold.
Right, so the groundwork is laid with all these philosophical and cosmological ideas. But how does this become something that, remotely resembles particle physics? This is where the combinatorics comes in, isn't it?
Absolutely. So source one, it goes on to introduce these combinatorial variables that are directly connected to those gunas we talked about. We've got S, which stands for sattva guna, and it represents the number of possible subsets that you can create from like a set of things. Then there's R, which is for rajaguna, and R is the number of elements within a specific subset. And finally, there's T, which is tamoguna, and it's the total number of elements in the original set.
Okay, I'm following, I think. But how do we visualize this?
Well, the source, it actually gives us this really cool analogy. It talks about clouds, raindrops, and hailstones.
Okay, clouds, raindrops, and hailstones. That's actually pretty relatable.
Right. So the clouds are like the set. The raindrops are the subsets.
Yeah.
And the hailstones, well, those are the elements within a subset. It's a surprisingly visual way to think about these, abstract mathematical concepts.
Yeah. So how do these variables go from this analogy to something more fundamental in this model?
Well, the source describes this as a process of differentiation. And the
Yeah.
idea is that the gunas are acting upon this initial unified state. Remember Shiva from before? Right. So the gunas act on this unified state, and it leads to these combinatorial variables becoming countable in phases. So first you have the potential subsets, S, then the specific size of those subsets, R, and finally the total number of elements, T. This progression from counting possibilities, basically, to counting specific elements is seen as a move from a state of unity to one of multiplicity. This is that key idea that we were talking about earlier.
So you start with a fundamental set, right? And then you explore all the different ways you can select elements from it. But where do particles come into this? I remember something about an origin set with n or t equals 4.
Yes, that's exactly. So the source focuses on this set that contains 4 elements. So n or t equals 4. And if you consider all the possible subsets that you can make from a set of 4 elements, ranging from having no elements at all to including all 4 elements, you get this specific count. It's 1, 4, 6, 4, 1. So there's one subset with 0 elements, 4 subsets with 1 element each, 6 with 2, 4 with 3, and one subset that contains all 4. And here's where it gets really interesting.
Because that very first one, the subset with no elements, that's highlighted as being incredibly significant, right? The idea of it like imitating emptiness.
Yes. That subset, the one with 0 elements, R0, it's absolutely crucial. The source, it argues that this imitating emptiness is actually the condition that allows for the Big Bang and for the evolution of the entire observable universe. It's almost like the void itself is a necessary precursor for existence itself. And then the source says, so an extension of elementary particles may only exist if it coexists with an anti-extension of elementary particles. This is huge. It suggests that the duality of matter and antimatter, it might just arise directly from this combinatorial framework.
Matter and antimatter as like two sides of the same fundamental combinatorial possibility.
Exactly.
That's a lot to digest. What about the other subsets, though? The ones that like actually contain elements?
So the source explains that each subset with just one element, R1, represents a fundamental unity, so oneness. And the number of these single element subsets, well, it's n, the number of elements in the original set. So it reinforces that condition of unity that we talked about before. There's this quote, it says, without oneness, the elements of the universe will disassociate like a scoop of sand falling through the fingers of my hand. It's beautiful, really. Yeah. So in this model, the particles, the ones that you see, they're these fundamental units of oneness. And they emerge from the differentiation of that initial set.
Okay, my mind is definitely being stretched here. We've gone from philosophy to cosmology, to this sort of abstract combinatorial game that's supposedly the foundation for particle physics.
Right.
So how do we actually get to real particles? This is where Source 2 comes in, and the idea of Rishons, right?
Yes, exactly. Source 2 takes this combinatorial framework and it tries to make it more concrete. It does this by introducing these Rishon-like elements. So the combinatorial variables, S and T, they get mapped onto these Rishons. The T Rishons correspond to T, and the V Rishons, well, they correspond to 2 times S. And what's really interesting is that the S and T variables can also be interpreted as like space and momenta vectors. And this is starting to bridge the gap to actual like physical properties.
Okay, Rishons. Now, you might have heard about those in some other prion theories out there.
Yeah.
So are these T and V Rishons the like truly fundamental building blocks in this particular model?
In a sense, yes. So the model proposes that T and V groups, they form these unique doublets. And these doublets are the fundamental components that make up the more familiar particles that we know and love. The source even touches upon the concept of electric charge. Initially, it's defined as T divided by 3, but later on it gets a little more refined and includes some other, quantum numbers in this more, it gets kind of intricate. There's a formula, and it involves this thing called Rishon number, which basically takes the place of the traditional baryon number.
So we're getting closer to something that kind of resembles the standard model.
Right.
But Source 2 makes a really crucial distinction about what these Rishons actually are, right? I mean, they're not just tiny particles whizzing around in space.
Exactly. And this is really what sets this model apart. The source explicitly says that these T and V groups, they're not dynamic particles existing within space-time.
Yeah.
Instead, they're, they're dimensional constituents of the space-time structure of quarks and leptons.
Okay, say that again.
So picture this. Think of quarks and leptons as 3-dimensional objects, right? And as these objects turn in space-time, they present different dimensional faces to an observer. And those faces, those are the T and V groups.
Hold on. So the Rishons are in space-time. They're what make up the space-time structure of particles themselves.
Yeah.
That's a pretty wild idea.
Right. And the claim is that this model, even though it's not, based on these rigorous mathematical foundations like the standard model, it can still reproduce the particles that we know.
Yeah.
And their symmetries, even the broken symmetries that we observe. It's conceptually similar to other prion models, but it takes this unique approach of Rishons being the very fabric of particles in spacetime. And the source, it even mentions this interactive model. Like you can actually see visually how different combinations of S and T, which represent the V and T elements, right? Well, you can see how they can represent the composition of different particles.
This is really making me rethink something.
Mm-hmm.
So we've gone from like philosophical dualities to these combinatorial possibilities and now to these fundamental Rishon elements that aren't just particles. They're like the essence of a particle's existence in space-time.
Mm-hmm.
And then the YouTube sources, they discuss how this all connects to spin networks, right?
Yes. The YouTube transcripts and the space-time and Rishon fundamentals material, they build on this idea of Rishon fundamentals, and they link them to combinatorial groups. And they suggest that a given order of group may constitute a spin network. So basically, these really abstract combinatorial structures are being connected to like the very geometry of space-time itself.
Okay, so what does that actually mean? How do these groups come together to form a spin network?
So the key idea is that a subset of these combinatorial groups, a subset that all share a common beginning letter, they use the example of the letter F. That subset constitutes the volume at a point, or like a vertex within the spin network. So all the groups that start with F, they define a particular point in the network.
And these groups are like built up in layers, like lower order groups combining to produce higher order ones?
Right. So the transcripts explain that the order R3 groups are created by the union of lower order R2 groups, and they have to share the same first letter too. Mm-hmm. So for example, if you have groups starting with F at order R2, like Fa and FB, well, those can combine to form an order R3 group, FBA. And this process, this combining and uniting, is how the network expands and becomes more complex.
So then these subsets they're further divided, and that's represented by like the lines or edges in the spin network.
Yes. So each subset of these groups, the ones that all share the same beginning letter, they get partitioned into even smaller groups. And the number of elements in these smaller groups ranges from 1 up to n1, where n is the number of elements in the group that's being partitioned.
Okay.
Each one of these partitions is represented by a line segment, and that segment ends at the vertex. And the number on the segment, well, that tells you how many groups are in that partition. And they even have a formula for the number of unions produced. It's j times j plus 1, all divided by 2, and then minus j. So like if j equals 4, you get partitions of size 1, 2, and 3.
So the more partitions there are, the more line segments are coming into a vertex, which means like a more complex volume at that point in the network.
Exactly. And the volume, it has this factor associated with it. It's the square root of j times j plus 1. And the source is very specific here. It says that this factor is linked to the count of relations between the Rishon fundamentals. So the source is suggesting that the geometry of these space-time volumes, it's made up of the relations between these fundamental elements. It's this whole network of relationships that creates the structure of space-time as we experience it.
What about those A and B letters that were mentioned? Mm-hmm. Those represent like empty volumes.
That's right. So A and B, that can be thought of as these empty volumes. And that's where the line segments in the spin network begin, not end. So they represent relationships that originate from these like empty spaces. And then they connect to the volumes that are represented by the other letters, like F, E, C, and so on. It's like a network of connections across all these fundamental volumes.
Okay, so Rishon fundamentals are elements of combinatorial groups. These groups form spin networks. The meeting points of these networks represent volumes, and the connections represent relationships between these volumes. And the geometry of the volumes is determined by the relationships between the Rishons. Mm-hmm. But what about particles and forces? How do those things emerge from this whole network? Because the last YouTube source, it talks about Rishon expressions.
Right. And that material basically says that the expressions of relating Rishon fundamentals in space-time are the foundational elements of the standard model particles and forces. So it's not the Rishons themselves that are like, dynamic, energetic things, but rather the ways in which they relate to one another within the space-time network. The relationships are fundamental.
And these expressions come in different like types.
Yeah. So for every single Rishon fundamental, and they mention C, E, B, A specifically, there are associated T and V type expressions. And when you consider them in groups of three, each type can be generic, prime, or flavored. So there are 4 kinds for each type. So that gives you 16 possible expressions for just one Rishon.
Wow. So 16 expressions for each one of these fundamental Rishons.
Mhm.
They could generate like a pretty large number of the particles in the standard model.
That's the idea. And it's important to remember here that the source, it reiterates that these T and V expressions, they aren't dynamic or energetic in and of themselves. They, and I quote, only compose the space-time structure of the quarks and leptons. So in this view, the real building blocks, they're not tiny little like balls of energy or something. They're more like fundamental relationships that give rise to the structure of particles within the space-time that's, generated by their interconnected network.
This has been an absolutely incredible journey.
Yeah.
We started with these abstract philosophical ideas about like unity and particularity. Then we went through a whole cosmological framework of creation,
Yeah.
and then into this whole combinatorial derivation of fundamental possibilities, which got mapped onto these Rishon-like elements that aren't just particles, but like constituents of space-time itself. And finally, we saw how their relationships within this network could create the structure of particles and forces. It's really a holistic kind of view.
It is, isn't it? And the themes are really striking. Like combinatorics, it could be this unifying principle, and they really emphasize this phenomenological way of understanding that goes, beyond just math. And then the idea that space-time itself is a product of these fundamental elements. It's not just a container for them. And then there's these recurring dualities too, like matter and antimatter, the T and V Rishons, and trinities like the gunas and the groupings of Rishon expressions. And of course, we can't forget that R0 subset, it's like the singularity before the Big Bang.
So the takeaway here is that we're looking at the standard model, but through this totally different lens, one that integrates philosophy, cosmology, and combinatorics. And the idea is that these fundamental Rishon elements they're actually dimensional components of space-time that exist within particles. And the web of relationships between these Rishons, well, that forms these spin networks that define the geometry of space-time volumes. And the way these Rishons interact, that's what gives rise to the structure of the particles and forces that we see and experience.
That's a great summary. It really is a pretty big shift in perspective.
This deep dive has been absolutely fascinating. It really does make you think about what's truly fundamental in our universe. So here's a thought for you, our listener. Could the foundational structure of reality be less about, energetic particles just moving through like a pre-existing space, and more about like a relational fabric of something even more fundamental, something that gives rise to both space and matter? It's certainly a lot to think about. Thanks for joining us on The Deep Dive.